Thank you. So I'm here to speak about blockchain privacy. Okay, I'm a cryptographer, and actually I have a dark role in cryptography. I break things, and I'm also an expert of hacking payment systems and smart cards. And cryptography is quite important because this is actually the most important disruptive technology we have. So we speak about crypto magic, which is my next slide. Okay, so crypto magic is doing things which are just impossible to do without cryptography. So, for example, with electronic commerce is not possible to do without cryptography. There is the famous N-square problem. You cannot manage keys without cryptography. Okay? Another thing which is not solvable without cryptography is a trustless payment. And this is something which has been invented in France. My company is the company which has shipped and sold the first EMV bank card to a UK bank. It's a French company. And the invention is about having this hardware with a private key, and the banker doesn't know the private key. So the banker cannot commit fraud in this system. It's actually the trustless system, and actually this system is the father of Bitcoin, because the only difference between the EMV bank card and Bitcoin is actually that we have decentralized and removed the bank. Okay, it's not needed, by the way. Recently, I went to a UK bank to open a bank account for my company. They have refused because there was crypto in the name of my company. They have refused. Okay, I found another bank, don't worry. Okay, but it's quite interesting. Cryptography is actually the core invention. Okay, and we have something which we had for 30 years in cryptography, which I call cryptographer's dream. Okay. So cryptographer's dream is about building these trustless systems and a trustless society. Okay? Though it's not true that they are completely trustless. You have to trust the source code. We have seen that in the previous presentation. Okay? And you have to trust cryptographers. Okay? So there are still people whom we need to trust. Okay? So we have crypto wallets. And of course, because they are fathers of the bank card, the best crypto wallets are the hardware wallets. Potentially there's no security in software, okay? And now the question is, why do we need this? So it's the trustless question, and why do we need privacy? Okay? To understand well why we need privacy, you have to look at what happened in Berlin a few days ago. A politician has proposed to Google to take over the former Stasi headquarters. It was all over in the press. Okay? What a wonderful choice. We should just say, yes, that's the right thing. Okay? Google have refused. Shame on Google. Okay? That's exactly where they belong. Okay? And it's a huge facility. There are huge buildings. It's really, really very comfortable. Okay? It's really the appropriate place for them. Okay? So in a society in which an individual is a slave tomorrow and has to fight against robots and algorithms for survival, okay? Privacy is our only hope to survive in the future society. Okay? There is this incredible imbalance of power between the organization, big, well-organized companies such as Google, and the individual, who is completely hopeless. Individuals cannot use their freedom. They just cannot because they are too stupid. They don't have the intelligence. The artificial intelligence will overcome it. And they don't have the ability to even calculate the risks. You know, in our life, everything happens once, and we are just not able to manage our lives properly. Okay? So the individual loses, individual without this privacy, which can be potentially improved, loses his ability to live a decent life. He's going to be a slave of a future society, which is going to, in some way, you either thrive because you are a profitable piece of meat, or you would rather be, put into disposal by the society because you are not a profitable piece of meat. Okay? So privacy is really here to defend the humanity against the future civilization, which is not potentially very good for us. Okay, it's potentially a hostile civilization. Okay, it's not coming from another planet, it's coming from this planet. Okay, so what kind of privacy techniques we have in blockchains? We have group and ring signatures, or privacy for senders. Okay, so in normal digital signatures, we have different properties such as completeness, soundness, okay, anonymity. And the anonymity in group signatures means that we know that the signer belongs to a certain set, like ABCD. And group signatures have big brother syndrome. It's like centralized and traceable, okay? And later, cryptographers invented something which we call the ring signatures, okay? If you look at the literature, I have published a paper about ring signatures in exactly the same volume in which the initial paper by Rivest is published, okay? And ring signatures are very interesting. They are decentralized, they are flexible, and they are permissionless, okay? So actually, I can co-opt some people from this room to participate in my ring signature without their permission. And this is very nice. This really can increase our privacy set and increase our privacy and anonymity, okay? If we compare to traditional signatures, traditional digital signatures, they implement this dual link. You link the document being signed to the signer, and you link it to the document. So there are two very strong links which have to be enforced by cryptography mostly, okay? Ring signatures, they actually remove the first link, okay? So you don't have the link to the signer anymore, and actually they break it in such a strong way that as cryptographers we call it unconditional unlinkability, because it's secure against quantum computers, it's even secure against something like, we call it infinite computing power. Okay, so it's actually a very, very strong notion of anonymity which you achieve in ring signatures. Okay, there are particular methods to do it. They are quite complex. It's like a very, very complex set of mathematical equations, which you can see here. And a ring signature is essentially a method to solve this system of equations. And more than one person can do it. Hence the anonymity that we obtain here. Okay? Another method to achieve anonymity is using tumblers. It's like a washing machine. Okay? So mixing coins with other people's coins. A lot of people do that. Previous method only anonymizes the senders. This method is senders and receivers. Okay? And an interesting proposal was recently published. It's called Möbius. And Möbius is interesting because Möbius is trying to fix Ethereum. You think that Ethereum is extremely good because it's programmable, but Ethereum lacks any sort of native privacy features. Okay, it's very, very bad on this side. Okay, so of course, maybe it can be programmed, but if you program something not natively, you slow it down, you make it expensive. Okay, so it's not so obvious that Ethereum can actually be fixed, but cryptographers are working very hard to do it. Okay, but it's interesting. Why would we try to fix something which was not properly designed in the first place, or it was not designed with the philosophy that we might want to do? Okay, I think there are some original sins of some blockchains which make that it's difficult to do something with them. Okay, so if you look how Möbius works, Möbius is a system in which the recipient is going to initially give to the sender something which we call a stealth address. So the stealth address, it's something like a method to derive public keys and secret keys independently by two different people so that they match to each other. And there are many different ways of doing this. The most advanced, for example, currently exist in the latest update of Zero Cash, like last month or this month update. Okay? But there are also simple methods to do this, which everybody uses if they have cryptocurrency wallets, like key derivation methods. Okay? And then what it's going to do is that the sender is going to send his money to a smart contract. So the address will be the address of the contract. Okay? And now the recipient is going later to withdraw his money from the contract. And this is where the anonymity happens. Okay? So the anonymity is a process in which here a ring signature will allow the recipient to prove that he's one of the people who has the authority to withdraw money, without actually revealing a single bit of information about which of the people who have deposited money there is currently withdrawing. And the crucial method to achieve this is called the key image. There is a cryptogram there. Okay, if you have a bank card, if you go to the shop with your bank card, sometimes the cryptogram, just a triple-digit cryptogram, is printed on your ticket. So it's a cryptogram, it's a random string of bits. It's not encrypted, actually. It's an authenticity feature. But it's called a cryptogram. Okay? Here, there is a cryptogram which we call key image, in blue here. And this key image is designed in such a way that the whole technology of ring signatures with these complex equations guarantees that the key image is actually checked and correct. It's basically part of our signature and it's checked. So there's a crypto magic which assures that this key image actually is somewhat probably good. And then we have this verification which consists simply of checking if the key images then don't repeat. And this is what prevents double spending in this system. It's just the simple check that the key image don't repeat, okay? But behind this, you have the whole cryptography solution which actually guarantees that if they are not repeated, then actually the system is secure. There's a cryptographic security proof, which is the ultimate guarantee of the security of the system. What I'm saying is absolutely not obvious at all that this is actually secure, okay? You have to trust the cryptographers or check the security proof yourself. Okay, so it's complicated to trust these systems. Okay, so this is how Mebius works, and Mebius is an add-on system for Ethereum. It can add privacy to Ethereum. Okay, Monero is a very similar system, but Monero works very differently. It also uses stealth addresses, maybe, and actually it uses them since the first day, and also uses key images. But in Monero, the key image is used at the sending moment. Okay, so you have no smart contract. Instead of sending money to smart contract, you send money to a recipient, which is characterized by his stealth address. Okay, and in Monero, you are using this key image at the very moment you create your transaction. You just mix with other people, and it's the sender who will be actually protected in Monero by this key image. So it's quite interesting that the same technology can be used to protect senders and receivers, the same technology of a ring signature. Okay, so I will skip a few more slides because we have very little time left. So I have a long technical presentation which will be available on my blog. Okay, and I will switch to another part. So Mebius, here's the problem with Mebius, is the cost. Because Ethereum is not natively implementing privacy-friendly operations and cryptography-friendly operations, okay, it's penalized. So it costs some money to use this added privacy feature on Ethereum. So actually the future of blockchains, which, you know, like which blockchain should I invest into? The future of blockchains, I will tell you, are those who will be friendly to implementing more privacy and cryptography in a sort of native way as opposed to big pain as you can see on this slide. Okay, so that's the interesting question. Okay, and I will move to this slide. I think there is something which is really essential in our society, is something which I call asymmetry here. What is the asymmetry? The asymmetry is that there are two sorts of privacy, really, which are sometimes distinct technically, as we have seen today. There is privacy for senders and privacy for receivers. And our economy is essentially asymmetric. We receive money from very few sources and spend them at many, many places. Okay? Most monetary operations are unidirectional. I give money to the shop, but I rarely receive money from that shop. Okay? So the economy is actually asymmetric. So this asymmetry is not a bug, it's a feature. So I'm not going to claim that some part of privacy is potentially bad. Okay? Privacy for receivers, for example. If I'm giving money to my shop and if they are tax evaders, maybe they don't need privacy. Okay? Now, what about privacy for senders? I will claim that privacy senders is a very interesting goal for the society and we should have it. Okay, so I think it's good, basically. I think you have good privacy and bad privacy. Okay, and not all privacy not all privacy technologies are equal. Okay, it's quite interesting because, of course, Bitcoin is sometimes associated to ransomware, which you can see on this slide. Okay. And some people bought their first Bitcoin because they had to pay a ransom, as a business, for example. Okay? But ransomware is exactly the place which exemplifies this asymmetry. Okay? Because the key feature of privacy for receivers, okay, which makes this sort of crime very, very important nowadays, is precisely that, you know, that the receivers are potentially protected too well by these systems. Okay? So I think that we need to think about the future of the society in terms of having more privacy, but maybe not every type of privacy is equally good. Okay, so I think I will stop here. I have 0 seconds left, so thank you very much for listening.
Thank you very much. Thank you very much for this interesting and stimulating presentation. I do agree that privacy is our only weapon in our digitalized society. Do you have any questions for Nikolas?
No questions. Yes, there's one question here. Yes, please.
Hello. Thank you for this interesting presentation. The thing is, I disagree on bad privacy or good privacy. There are bad people or good people. And this is, as you have said about cryptographers. How can you trust them? And there is who...
You cannot.
This is the question of who regulates the regulators, who have the power, and all these big questions. But at the moment, all these issues are helping for motivating business. How can you see this with artificial intelligence in the future? Because the privacy and the blockchain with artificial intelligence are going to be a big issue in the near future. I would like to have your comment on that. Thank you.
Yes, artificial intelligence is the technology which is against and going to be against the humankind. This is going to be very bad for us. You see, so privacy is our weapon. And the smart card is also our weapon. You know, the personal technology in which you control your security because you control your hardware is our weapon.
So, any other questions? Yep. Question?
Hi, hello. Thank you very much for this wonderful presentation. My name is Jonas Lanis, and I would like to ask, what is the point of cryptography when it's time to cash out and you have to recognize the cryptocurrency because you got to do it through a fiat gateway? So how can you avoid that?
I'm not sure I understand the question. So again, cryptography is the core disruptive technology. You cannot get rid of cryptography, and we cannot build any interesting systems without cryptography. So if you're asking what's the point about cryptography, you know, there is something wrong in the statement, but I don't really understand your question.
What I mean is, assume that I get paid in Monero, let's say.
Yes,
okay?
yes.
And I have to turn it into fiat in order to use it in the real economy. When I turn it to fiat through an exchange, I go through a KYC, which means I'm verified as a person who I get the money from this, so I'm tracked.
Well, this is how our society needs to police the crime, you know, and therefore, you know, potentially this is never going to go away.
Thank you very much.
Okay.
Any other questions?
What do you think about ZK snarks-based mixers compared to ring signature mixers like Miximus for Ethereum?
Yes, so this goes back to the question, can you trust the cryptographers? I have lived in cryptography in the 90s where people have been improving security every year, and at the end of the 90s we had very good cryptographies. And somewhat, since that moment, like the year 2000, cryptography has started degrading slightly each year. And today the quality of cryptography is rather going down every year than up because of so-called untested assumptions which are used more and more frequently. So zero-knowledge snarks are wonderful technology, and it's really, really clever. It's rocket science, and I know some of the creators, etc. But there are reasons to mistrust this technology on the fundamental cryptographic level of not being sufficiently studied. There is a problem of how much effort you spend on code making, designing cryptography. okay, and how much you cheat, and nowadays cryptographers cheat a lot, and how little was spent on trying to break it, to cryptanalyze it. You see, typically maybe it takes 10, 20, 30 years to crypto system to mature because code breakers eventually have managed not to break it. It's a Darwinian process in which cryptographic systems emerge as secure because also the most brilliant minds on this planet have actually tried to break them. It's not the case for zero cash. Okay, nobody has yet tried to break it. So there are some problems with it. Yeah.
We have 1 more minute still for another question. Okay. And okay, one last question.
Yes, I was just wondering, you talked about Monero and it being kind of very cryptic and private on the aspect of things, but also how do you think it's going to be seen long-term spectrum? Because with Monero having bad reputation for taking advantage of computer systems and web mining and mining in systems through web-based and Java-based protocols. For example, Monero was known to have an affiliation with CoinHive that would pretty much jack computer systems, and Salon.com got in trouble for that, not notifying their website visitors. So do you think those privacy coins are going to impact the whole reputation of that spectrum long-term?
Yes, so I think Monero indeed got some bad reputation because of this, but it's not really a bug. I think it's a feature, you know, because Monero needs somewhat to have a large number of participants in their system, and therefore they have adopted policies such as CPU mining and other things which enable this larger participation, and these policies have this unfortunate give this unfortunate possibilities for people to abuse of other people's systems, to mine, etc. So I think this is sort of inevitable that there will be some problems, but I think they are not that significant.